Welcome to this particular module, and this is again a experimental component of our lecture or theory class. The today's module will be focusing on how to use 3D printing technique. Now 3D printing, as you know, has evolved several tens of folds from last few years, and now it has been people are exploring the the beauty of 3D printing into several different applications, right from automotive to medical devices. On the same line, we will be also discussing on if there are two 3D printers, right, or let us say that if the 3D printer is in a remote location or other laboratory and you are placed in other laboratory, that means can you access that particular 3D printer from a different place? Let me give an example. If my lab has a 3D printer which I keep it open for anyone to use, and if you are in a particular college anywhere in the world, okay, can you operate my 3D printer through your place? So, we will be showing it to you how this remote operation can be done, how can you use it if the 3D printer module is in one particular lab or one particular place and you are located in some other particular place. Okay. So, that is the idea of showing you little bit little bit of advanced version of how to operate this 3D printer, and I request one of my additive manufacturing guy to show it to you how this 3D printer can be utilized, right. So, I will request Saeed to discuss about this 3D printer and take it over.
Hi all, now I will be speaking about 3D printing materials. So, here you can see a 3D printer, and this is a FDM 3D printer as I am explained about FDM. Here there will be a filament like this, and this filament is given through a heater, and then it is coming through a nozzle and it is deposited on a platform. So, here I will be explaining about different 3D printing materials for FDM 3D printer. So, the first one is a PLA material, polylactic acid. So, this is an example for polylactic acid material. Here the filament diameter is 1.75 mm, that is a standard diameter 1.75 mm, and another standard is 3 mm. Those are the most used standard diameter for filament in 3D printing, in FDM 3D printing. So, PLA stand for polylactic acid. This material is also biodegradable. So, it is having low cost, and this is the most widely used 3D printing material. And the second one also is you can see this a white color PLA material, and this was a black color 3D printing material. So, next one is ABS, that is acrylonitrile butadiene styrene. That is also one of the widely used 3D printing material, and ABS is more stiffer than PLA material. So, for the application require more stiffness and more strength, people use ABS 3D printing material. One major difference between PLA 3D printing and ABS 3D printing is for PLA 3D printing, the printer do not need any heat bed. That means there is a platform where the material is deposited. If we are using the PLA material, there is no need of any heating in the printing platform, but for ABS that will shrink a little bit if it is cooled rapidly. So, that will need a heated 3D printing bed, and ABS is the cost wise that is similar to PLA, And next is flexible materials. Flexible material, there are several materials. Here I have an example. Thermoplastic elastomers. This is a thermoplastic elastomer material. Here you can see this is very flexible. And this material have one more specialty. This is a neon material, so this will glow in the dark. This can be used for making structure which absorb vibration, or if you are making something need to be flexible, or some connectors, we can use this kind of flexible materials. Next is here HIPS, HIPS material, that is high impact polystyrene. That material is mainly used along with ABS, or it can be used by with itself. If we have a dual extruder 3D printer, the 3D printer which can extrude two materials, or it have two extruders to separately extrude two materials, and we can use ABS for printing the object and HIPS material for printing the support material. And one specialty is the HIPS material can be dissolved in a solvent. Next is PETG, that is a modified version of polyethylene terephthalate. That is also people are used, but it is not wide as PLA or ABS. Next is nylon 3D printing material. Here you can see this is comparatively flexible, but not as flexible as the flexible materials. Nylon material is mainly used for the application which need high abrasion resistance, high impact resistance also. So using this nylon material we can print objects like gears for gearbox, etc. And next is ASA, acrylic styrene acrylonitrile, that is also not widely used. The next one is carbon fiber filled materials. Carbon fiber filled material means suppose this is a PLA material, we need a more strength, we need a material with more strength, but the properties of the properties like melting point of PLA. The manufacturer will take fine powder of carbon fiber and fill and mix it with PLA material to make this kind of filaments, and the filaments will have higher strength compared to PLA, but less than carbon fiber alone. So the material will be filled with carbon fiber fine particles. So one upgrade we need for the 3D printer is while using carbon fiber material. Carbon fiber material is high abrasive, so the extruder we are using should be capable of carrying or extruding the carbon fiber filled material. Here we are using a 0.4 mm brass extruder, but if you are using carbon fiber filled material or other filled material, the nozzle diameter can increase due to particle abrasion to the nozzle. And this will be similar for metal filled material also. Metal filled material is mostly used for its unique finish. If you are using a metal filled material, the object finish will be very much similar to a metal, but for printing using metal filled material, we have to upgrade the extruder for handling metal filled material. Wood filament material also similar to the carbon fiber or metal filled material. Fine particles of wood is infused in PLA or ABS material and can be used for making objects. Wood filled material have one specialty, like it can be easily sanded. So using a sandpaper we can easily sand the outer surface and make the finish look good. The wood filled material, the appearance will be similar to wood material. And the final is PVA, polyvinyl alcohol. This is also not widely used. The most widely used are PLA and ABS. Then flexible materials, nylon and HIPS material or wood filled material. In cost wise, PLA and ABS have the lower cost, and the flexible material, HIPS, nylon, ASA, carbon fiber filled material, metal filled material, wood filled material and PVA, those are of high cost. And for easy printability, PLA has the most advantage, and if the carbon fiber filled material or metal filled, wood filled material is the fine powder is mixed with PLA, that is also easily printable. Easily printable means a 3D printer with low specification can print that. For printing ABS or thermoplastic elastomers or nylon or any other, we may require a heated bed. And for printing carbon fiber, metal and wood filament will require upgraded extruder. Now I will show you how to convert a 3D object which we made in Autodesk Inventor to a 3D printable file. There are several steps to convert from a 3D object to a 3D printable file. So first we have to take the object and convert to a STL file. Then the STL file should be configured or converted to a 3D printable file or machine readable file. Now I will explain about converting a 3D model to a STL file, then slicing that STL file for 3D printer. Then I will explain about a software called Octoprint for remote 3D printing capability. Normally a 3D printer will have a memory card slot or a USB slot, or it can be connected directly to a PC. So if it is directly connected to a PC, we can operate the 3D printer using that PC. But the problem is, suppose our printing need around 24 hours, so the PC also should be on at all time. If there is any interruption between the connection, the 3D printing will pause and our time and the material will be lost. So another way of operating is using a USB pen drive or a memory card. In that case, we have to go near the 3D printer and insert the memory card or USB pen drive, then have to give command for start 3D printing. In this method, using Octoprint, we can control the 3D printer using a web interface which can be controlled through internet. So we don't have to go near the 3D printer directly. We can give command for 3D printing from our PC, which is at a remote location. Then I will explain about a 3D printer and the basics of 3D printer. This is the object we made using Autodesk Inventor. Here you can see this is the top part object. So we want to convert this object to an STL file. STL file is a vector file which is used for 3D printing. In this Autodesk Inventor software, all objects are saved as IPT file. So we have to convert this object in IPT format to a vector file. So I have already opened the top part file. Then I will go to files. Then I will go to print here, the print option. Then I will select this send to 3D print service. So here we can see the length of the object was 60 mm as we discussed, and the height was 60 mm, the same height. This is the length and this is the height, and the width was 5 mm. Width means the thickness is 5 mm. Now one more thing we have to keep an eye on is click options. There is a option for units. Here we have to select millimeter. In STL file there will be 60, and the object size and the object we have designed will be different. So we have to select millimeter, then click OK. I will click OK, and I will select a location. This PC 3D objects. So I will use a software called Repeater. So you can go to Google. You can go to Google and search for Repeater. And the first link comes when we search for Repeater. This is the link. Here you can choose this button if you are using Windows. If you are using Linux, you can click here, or if you are using Mac, you can click here. I will click here, and here there is a download without donation. I will click here, and I will download it. So I have already installed it. This is for you to know how to download the Repeater software. Here, this is the print volume. I have configured this print volume for my 3D printer. This square you can see, this is the print volume, and there is a dot here. This is the origin of the extruder. So the length is around 170 millimeter, and the width is around 20 centimeters. So the object, there is a option for object placement. I will click add object. And I am selecting the part. The file I have converted to STL file, top part. So here you can see, in this software also you can use the scroll button to zoom in and zoom out, and click the left button of your mouse to rotate the view, or you can click on the mouse roller, and move this view. Here I will place the object somewhere near the origin inside the print volume. So I will use right button of my mouse, and I will drag it here somewhere near to the object. And next is, after the object placement, there are some other option also. You can make copy object. Suppose you need this object, then you can just click copy object, and how many extra copies or object you want, it will ask. I will just put it as 1 and click copy. See here there are two options. There are two objects. So I will just delete it, and there is a option for rotating the object. There is an option for scaling the object or mirroring object. After placing the object, we have to go for slicing. Slicing means the object is sliced by layer, and then it is converted to a machine readable code. Here we will be using G codes. The 3D printer is configured for G codes. So this repeater software will give output file as a G code file that we can upload to the 3D printer. Here in this slicer we have some options for like adhesion type. If we are having any adhesion problem, that means a plastic material, suppose here we are using PLA material, it is heated and extruded through a hotted nozzle and is depositing on a plate. So since they are different material and there is chance for not adhering the material on the build plate. For that we can choose, there are two options, brim and rough. Here there is no adhesion problem, so I will click none. And next is the quality. The quality means the height of each layer. Here the default option is 0.2 mm, that means 200 microns. This object will be sliced by 200 microns thickness, and there are options for slicing at 150 microns or 100 microns. If we are giving it is as 200 microns, the printing height, the printing layer height will be 200 microns, and we can see the object layers which the 3D printer has deposited. If we want some fine smooth finish for the object, we have to select better quality. But one trade-off is, if we are selecting this 0.2 mm, the time will be, suppose it is as X, and if we are selecting 0.1, there will be 2 times layers will be there for the same object. So the total time taken will be 2x. So I will select 200 microns, that will be enough for my application. And support type, there are different type of two different type of supports. For this object there is no support is needed, so I will select it as none. And the speed of 3D printing, we can select different speed. The slowest speed configured for the 3D printer is 30 mm per second, and the fastest speed is 60 mm per second. I will choose 30 mm per second. Another thing is, we are making a 3D object, so maybe our point of interest will be on the outside of the object, not the inside. And if it is not a functional part, then we don't need material to be 100% material. The object should not be 100% material. So we can give some air gap inside that to save some material, but from the outside the object we have printed will look the same. But I will choose, for my application I will choose 15%. Then I will click slice with Cura engine. Now it has came to print preview. So here in the printing statistics, estimated printing time. The estimated printing time is 1 hour 19 minutes and 41 seconds. The layer count, the number of layer is 25 layers. So we can just multiply 25 layers into 200 microns. That we will get 5 mm. And total lines, the filament needs, that is also important. This 3D printing will require 4000 258 of filaments. So this is the 3D estimated printing time for 200 micron layer height, and I will show you with 100 microns layer height. It is almost double. Here you can see the filament need will remain the same. I will go back and change it as 200 microns, and I will change the infill density to show you. I will change infill density to 100% and I will slice it. Here you can see it require 6403 of filaments, that means 6 meters and 40.3 centimeters. I will go back and change the infill density to 15% and slice it. So I discussed with you about connecting a 3D printer to a PC. If we have connected the 3D printer, we can directly connect the 3D printer to this software using this button, and we can click print here. But since we are not printing directly, we have to save the file, save the G-code file. Here you can see the save as type, it is a G-code file. File name is topart.gcode. We will save it. I already saved one, that's why it is showing a confirm. I select yes. And if you have connected the 3D printer to this repeater software, there is a manual control. Here you can see there are some options to control the 3D printer. We will be using Octoprint software. So Octoprint software will also some functionalities. We can go through that. The software I am using is Octoprint. We need a Raspberry Pi for running the 3D printer. We can download the Octopi operating system for Raspberry Pi from this octoprint.org website. And for installing this Octopi software, we will require a new SD card, or you can use an old SD card. We have to format that, and using a operating system installing software, we have to install the Octopi software into a Raspberry Pi memory card. Here you can see this is a Raspberry Pi. Here this is a Raspberry Pi case. I will open this. See, this is a Raspberry Pi 3 model. I have installed Octopi into this, and this is the power, and this is the USB port for connecting 3D printer, and I have connected this Raspberry Pi to using a LAN cable. After installing the Octopi software in Raspberry Pi, then we have connected Raspberry Pi to a LAN port. And next step is we have to find out the IP address of the Raspberry Pi. You can use any IP scanner. Here I will type my username and password. Username is bslab. Here see, I got a screen with options to control the 3D printer. Here in this temperature tab you can see the temperature. This red line is actual temperature of hot end or extruder. The blue line is actual temperature of bed. Here in this 3D printer there is no heated bed, so we can avoid this blue line. Next is in the control tab, here webcam streaming loading. You can connect a webcam to the Raspberry Pi using the USB cable, and you can see what is happening in the 3D printer through this window. Currently I have not installed web camera, and there is option to move x-axis or y-axis. Here to move x-axis towards right side, this is moving x-axis towards left side, this is moving y-axis away from us and moving y-axis away from me, moving y-axis towards me. This is a home button to home x-axis and y-axis. Before starting any print, the 3D printer has to go to its home position to calibrate. Then only it will start 3D printing. This is for moving z-axis, and there are switches for turning on fan, turning off fan, and moving the x-axis at 10 mm at a time, or to extrude, retract, and so on. Next there is a G-code viewer. Next is terminal. If you want to intervene the actual G-code and you need something, if you need to put some G-code manually, you can use this terminal window. And there is provision for taking time-lapse photo of the 3D printing object. We can use this. For using the time-lapse option, we need a webcam. And in this Octoprint software, there are a lot of plugins to add. One plugin I have is history plugin, so I will know what all things I have printed and how much filament is used for that, printing time it took. And another plugin I have installed is to calculate the cost. Here you can see the uploaded G codes. This is a top part G code I have already uploaded. Here using this upload button we can upload G code files. I have again uploading. This is the top part.g code. We can sort this as upload date, and if we select it, it will show how much it will cost for me to 3D print this. There is a formula in the backend. I have only included material cost, that's why it is very low. This 231 rupees. First I will select for 3D printing. First I will select, and then there is a load and print button. I will click that. Before giving 3D printing, I will explain about my 3D printer here. Now I will explain the different parts of the 3D printer we have in our lab. This is the printing head. This has two fans, and this is the extruder. This is how filament are fed into the extruder. There is a motor, stepper motor, for extruding the filament, and filament is kept on a roll here. And this is the 3D printing bed. This was the original display for the 3D printer. We have customized for our purpose. So this is the new screen for this 3D printer. There is a heater here inside. There is a heat sensor to know the exact temperature of the heater, and this is the nozzle. This is the x-axis, left and right. The extruder will go left and right, and this is the 3D printer bed. This will go in y-axis towards and away from me, and this is the z-axis. For this particular 3D printer, the y-axis and z-axis are combined. So here the 3D printing bed is on y-axis, and the y-axis will move in upward direction, and the nozzle will only move in x direction. For moving in z direction, there are two motors, one is here and one is here, and there are linear guide rails for precise movement in one axis. There are linear guide rails in x, y and z axis. Here you can see a switch. This is the limit switch or end stop switch, which is used while calibrating the axes. Now we can start 3D printing using this 3D printer. Now I have selected this top part, and I will click the load and print. I have clicked the load and print. Now you can see the x-axis has calibrated. Now y-axis is going, it is calibrated, and z-axis is moving towards top side. It will take some time to reach to the end stop switch. Z-axis is also calibrated. Now you can see here in this graph, the red line is at this point. The target temperature of the extruder is now 205 degrees Celsius. Here you can see another line, that is the actual temperature. Now it is at 77 degree, now 80, it is increasing. It will reach 205 degrees Celsius, then the 3D printer will start 3D printing. Now the nozzle temperature is around 205 degrees Celsius. It has started. Here you can see the nozzle is moving along the lines which is defined in the machine codes, and it is extruding material like this. You can see this is one model we have printed in our lab. This is for another project, and here this is a white color PLA material. Here you can see this is a object made using black color PLA. Here you can see the layers, and here also there are some lines. If you closely look, the lines will be of 200 microns height. Now we can go back to the 3D printer. You can see it started making a rectangle in the center and two holes in the two sides. This 3D printing will take around, it will take more than an hour. So we can see after the 3D printing finish.